Hey everyone. Hi, welcome. Hi, I should introduce myself. My name is Adam. I just graduated from MIT last year. I now work at Meteor Development Group. Some of you guys might know our open source framework Meteor, hosting platform Galaxy. We also have a separate project called Apollo, which has to deal with actually passing data into the front end of applications, something that I think a lot of you guys are probably dealing with right now in building out your web apps. All these are really useful tools, and all of them have a lot to do with web development, which is something that I pretty much never did when I was at MIT, which I've heard is kind of among the shoes of a lot of you guys right now. How many people in the room have done web development before taking this class? Just by show of hands. Right, so just a few of you, and so first of all, how many of you in the class are using Meteor? Show of hands. All right, no worries. So in that case, I'm going to assume you guys are using NPM. How many of you guys are using an Express server as your backend? Cool, and how many of you guys are using APIs? Okay, so a fair number of you guys. In preparing this talk, I kind of went through a history of what web development has looked like. You know, since we were kids growing up at kind of the early ages and the inception of the internet to now the kind of face of web development is, and what you need to do in order to be successful as a web developer. What kind of things you need to keep in mind. So yeah, I'm just going to jump in. I'll also like to add if there are any just like random questions throughout, if you want to like raise your hand or shout them out, or if you don't understand something, you want me to repeat something, that's fine. I'm going to start off essentially with just a brief history of where web development is, talk a little bit about what APIs are, why they're useful, how web apps are architected and what the infrastructure is behind them, and then I'm going to do a demo with all of you guys. We're going to walk through a tutorial together on actually setting up a GraphQL API, something I think you guys heard about from the Facebook person who came in here and gave a talk. Cool. So, first of all, I wanted to go back to like the first days of web development. So, I tried to find the oldest websites that I could. And somehow Warner Bros. Still has their like Space Jam, like original website up there. I don't know if you guys can see that. It's kind of poor font. But essentially, at the outset of web, a website was nothing more than a host for static images and text. Right? So you go over here and you click on a link, Jam Central, and it brings you to a text page with an image that says what Jam Central is. Where you can like click on more things and walk through those and get more text and more images. And that's all that web pages were. Web pages were around, a lot of people were interested in them. That was the era of the .com boom, but it was pretty much just to give you information. There's nothing to interact with. You would log on to a website and maybe read about a company's portfolio or their partners or restaurant's menu, but you couldn't make a reservation online, and you couldn't interact with a forum, like Reddit, for instance. There was another one. I had a lot of fun looking at these old websites. I don't know how many of you guys, like I remember logging onto that Space Jam website like when it was launched, like way back when, and I'm so surprised it still exists. Here's another one, which is like the trial of O.J. Simpson that CNN should really take down. And you can go, and they even have this section on here, which is like view comments from other users. But this is people who had to email CNN with their comments so that CNN could make a new web page to post their comments. Right? This wasn't something that anyone could just do on the fly. In order to add any content to a web page, you had to add it to the web page's database and then reload the server that actually was spawning that website for any internet user to view. The first big development in web, as far as web development is concerned, is Web 2.0, where now it's possible to have a lasting interaction with web pages. It's able to open up a forum. You can interact more easily with the database. You can you can have components that have much more complexity to them. And so this was in 2005, shortly after the launch of Web 2.0. This was Reddit's first day online, basically. So this is the first iteration of Reddit. You can see it's on Firefox from way back when. And oh yeah, this is just a funny story. In 2005, when Reddit launched, the way that they created buzz about what was going on there and what was so great is they made thousands of fake accounts. And everyone in Reddit was just working around the clock, making fake comments and fake posts and interacting with themselves. Just so people would think that there was this large growing community. And this was because people didn't see the internet as a place where you could have these kinds of relationships. They didn't see the internet as a place to engage. So far, they had only been part of an internet where they were given content, where things were just handed to them. They would digest them, write them down on a notepad, or print them out on a computer or in their printer and take it with them in the car, like MapQuest. So that's why Reddit needed to have all these fake accounts, because the value proposition wasn't so clear. It wasn't so clear that the internet would be what it is now. Shortly after this came Flash. So Flash, now you have the ability to embed audio and video and do much more than just engage with text or engage by uploading files from your computer. You can have games. These are three of my favorite games. I don't know if you guys ever went on Newgrounds or Addicting Games or Miniclip, but I loved Flash games growing up, and I thought Flash was the coolest thing. But sadly, Flash is dead. And the reason that Flash died, among other things, well, I think Flash's final nail in the coffin, at least, was Steve Jobs wrote a letter. It was just an open letter in April 2010 saying, Flash is no more, HTML5 is the way to go. HTML5 allows you to have audio, video, embedded elements, and you don't have to have all of these wonky button interactions that you do with Flash. So here's an example of a really beautiful, if it loads, HTML5 page that really takes advantage of the complexity and whatnot. You can scroll around and there are all these really cool animations and pretty visuals. It's nice. It's way better than Flash. And in fact, right now if you try to go, if I were to try to go to this place, Chrome would be are you sure you want to enable Flash? Are you positive? And then shortly after I exit it, it'll just turn off Flash, because it has all these security. I don't know if you guys remember this. No? Alright, it's just me. Terrible website. Anyway, so the internet is becoming a much more native place to have web applications. It's no longer the case that you need to have Flash and these other elements that you're pulling from out of nowhere and these complex database calls. You can now do a lot more with HTML5. There's more infrastructure around having interactivity with Web 2.0 and the likes that come out of that. And lo and behold, in 2008, we launched the App Store, which we didn't know it yet, but would change web development completely. And we'll talk about why in a little bit. This is the first iteration of the App Store, when App Store was actually still part of iTunes. You can see on the little left-hand side, it's iTunes U, iTunes Latino, which I think they depleted lots of this stuff. Anyway, little tiny gems from history I scrounged up as I was looking around. So, can anyone guess why the App Store had such a big impact on app development? You feel free to say stupid things. I'll probably say stupid things. Discoverability is a huge one, right? Because before, the only way to be discovered before the App Store was to be on Google and have people hitting the right keywords. And people, when they were searching on Google, were generally looking for information. They weren't looking for a way to actually interact with something, whereas the App Store was made expressly for that purpose. You have an app and you are supposed to interact with it. That's changed somewhat as time has gone on, where now when you're searching on Google, you might be looking for something to interact with. You might be looking for an online calculator that's going to do date conversions for you. Or you might be looking for a forum, but it didn't used to be that way. But another big reason is because of the way that we architected our websites from beginning to end. And since my focus is more on architecture and building out a reliable infrastructure, that's something that I want to talk about and its effect on web development. This is just another stat of how important the App Store is. After being launched in 2008, after a few short years, it had over 45 billion downloads. And in 2013, which was now 5 years ago, the average iOS owner had 41 apps on their phone. I think that might include the bloatware that Apple included, but it's still a big number. So as promised, let's talk a little bit about architecture. So, you guys familiar with these like weird diagrams I have on here, where they're like little tubes and arrows and squares? And have you guys seen these before? Kinda. Might know what's going on, might not. Well, we're not going to make anything super complicated out of that, but I do want to talk a little bit about what architecture looked like, at the outset, up to maybe like right before when apps came to fruition, and then kind of guide us toward what they look like now. Somebody pull down one of these guys. So any good diagram starts with client, which is your computer, and it sends some request to a server. I don't know what like the proper symbols are. I'm just going to draw random things. But let's say we're back in the age of static text, right? So it sends a request to the server, and the server maybe has a bunch of stuff already loaded on it, a whole bunch of HTML, and this request just says maybe like ID equals some random thing. So it's like, okay, well I'll send you back this HTML document. That's it. Here you go. Here's your little document. And you can display it on the page. That was easy, right? You didn't really need that much going on. Maybe you have some more complicated servers where they then send your request to a database that has the information that you're looking for, that even has the HTML that you're looking for just to be more secure, that maybe does some authentication, whatever, sends it back, and you send that to the client. Right? And maybe generally you have a few routes in here. So if you're on, what website were we using before? Let's not do Flash. If you're on like that ojsimpson.com one, like cnn.oj.com, maybe you'd send here to like /trial. And the ID would just be trial. And it would go and find the HTML for the trial. And it would just send you back the HTML for the trial. That was all well and good. And then you had some more levels of interactability. Maybe now you're on a forum, like Reddit, and so you're on a page, and maybe you're on R Funny or something. There's a post, and then comments, another post, whatever. And you're talking to the server, you're just like on this page, you already have the elements loaded, the HTML is already there, the JavaScript is already there. How familiar are you guys with like, actual code generation on the web? Like, if you don't know what I mean by that, then also raise your hands. Like, what the hell is code generation on the web? Cool. So, in this case, I'm talking about when you are actually on the website, it has some of the things already loaded on the client side. Your computer, when you go to a web address, might already load some of the default elements. Even today, if you go to facebook.com, it'll have a whole bunch of like little components that it has loaded, and then it'll just have spinny bars on each of the components, right? Have you guys seen that before when your internet's really slow? So that's stuff that's already on the client. Then there's data that needs to populate that, but then there are some components as well that are only on the server. Maybe you're using an outdated version of Adobe, even though you're using an outdated version of Adobe, but it doesn't know that on the client side yet, or doesn't have a banner popped up. But once you send a request to the server, it sends you back that component to render that banner. But then on top of that, for the component itself, like in Facebook's news feed, for each tile, maybe you need to get a different amount of data. Right? So when I'm talking about code generation, I'm talking about putting all those different pieces together to make the full vision of your web app. So, for instance, in Reddit's case, maybe you're on this page and you want to just upvote a comment. So you pass it upvote. Just some random command to this server, and it makes some change to the database, and returns back to you, and maybe it sends you like a 200. You did. Good job. You made a thumbs up to that comment. And then now that component probably has to send a new thing back to say like, hey, update me, I have a new comment, right? So it then looks again in the database to verify there is a new comment, sends it back up, and sends it back over. And now this interaction is going to happen on any Reddit page, and it's going to happen on any subreddit. And if you go into a comment and want to ask anything, it's going to go through, in a lot of cases, the same server, or maybe a cluster of servers, and go to the same database, or perhaps a cluster of databases. And it kind of has just this one like monolithic path to go through every single time that you want to make a request. Well, this was really problematic in the world of apps, because you have, let's say you've been working on a website for 10 years. It's a lot of stuff you've probably written in your repositories. It's a lot of logic that you have in there. It's a lot of data that you have in databases, and custom integration that you've built with third-party tools that maybe you've built more stuff on top of that was specific to you. And now, they're not getting data in the exact same way. Right? Your iPhone isn't going to load, it might not be able to load JavaScript or HTML or CSS nearly as fast as a web browser. And you need some ways of dealing with that, along with the point that some things are just formatted completely differently. And you can't do things on phones the same way that you did on computers. So the first solution to this was, screw it, let's rewrite everything. And companies that were starting to have an app would just say, you know what, we don't have that much work, we'll use our databases, those are fine, but as far as our server code and our client code, we're just going to have to rewrite it. That was a lot of overhead. For a long time, people were just being like, I am hiring exclusively iOS engineers or exclusively Android engineers, and I need you to port all of my existing code over. Until this idea started to really materialize in people's minds of the idea of a microservices architecture. Which, by the way, I would want to start with saying I'm not endorsing the microservices architecture, but this is a history. I think that there are a lot of problems with it. Are you guys familiar with microservices or monoliths, the things that I'm saying? That's fine. Probably the way that you guys are designing your web apps is following one of these two patterns, either a monolith or a microservices architecture. You either have all of your data and servers in one place and all of your traffic is going through all of them, or you have multiple different servers, all that have different purposes, talking to different databases that store different information. Do those sound reasonable? Like, do those descriptions sound like the things you guys might be doing? See nodding, all right, cool. Any of you guys think you're doing something just completely different? Okay. Any of you guys are just kind of like plugging in things and other things are happening behind the scenes and you don't know what's there, just no clue. Like plugging things into Express and you have an API and a database and like things happen, but you're not really sure. That's fine. That's all fine. So this pattern is, usually really concerning when you're trying to build a really big application. When you're just trying to build out an MVP or start on a simple web app, it's okay to not understand any of these architectural principles. It's okay to it's okay to not worry about distributed systems, or working on a cloud, or where you're hosting your application. Those are all things that come later down the road. But there are a lot of decisions that you make early on that can affect those later decisions. And that's what these companies found. They had made really early decisions saying, the web is where it's at. Everyone's going to see me in this web browser. The current state of the world is the way that the world will always be. And so I'm going to make my app, or my website, the way that everyone else does, and things are going to be fine. And that, as we saw, people just porting over giant amount of code didn't really work. And so they started with a microservices architecture, which I think I have a diagram of that, actually. Oh yeah, that's what I just said. So this is the idea of a microservices architecture. You have a client right here that might pass some authentication, some identity provider to a layer here called an API gateway. Not really important. In fact, you don't even need to have an API gateway. You might just communicate directly through an API, which then sends out that request to one or many different microservices. So let's say that you, someone want to give me an example of like an app that you're building? Anyone? I know some of your names, so I'll just call them out. Alright.
Like a book exchange?
A book exchange. So like, you have a used book and you put it in and someone else takes it out, right?
Yeah.
So maybe for your book exchange, you have your client interface, and there are a couple of things that you want to do. You want to be able to see all books, right? And you want to be able to update books, probably. Add one in, take one out. Additionally, maybe you want to see users. Maybe you want to have interactions with users as well. People who gave you this book. You want to make sure that you're not getting a book that's been sneezed all over, or some weird stuff like that. And maybe you also want to see locations. There are a lot of different places where there are these book drops. Where can you find them? And so you might have, you might have each of these three be a different microservice. You have a server for books, and you also might have a server for users, and you might have a server for locations. And each of these might talk to its own database too. Sorry if my drawing is terrible. And your application, can now breathe a little easier knowing that you can talk to all of these different services. If you want to say, what are my books? You might send a request to the book service, and with your ID, you say authenticate me, and return all books. Maybe there's some some special magic you can type in, and it'll just give you back all your books. Talks to its database, makes a round trip, and just gives you all the books. And now, things are a little bit easier, because when you have things separated into these little components, you can now make it more available for other kinds of applications. So your iPhone application, or your Android application, doesn't need to rewrite the wheel, because you don't have a ton of logic baked into the fact that you are a browser. You might just call the books endpoint, this book server over here, microservice, and say, what are my books? And then based on that data that you receive, you can either pass it to the web application that you're using on Chrome or Safari or Firefox or Internet Explorer or Edge, whatever that's called, or maybe to an iPhone app or an Android app, or in today's day and age, why not to a Messenger app or a Slack bot? So by freeing up your data to be sent through these different pathways, it makes it a lot easier to develop quickly, is the argument. However, this is something that you don't necessarily only get out of microservices architecture. You can architect a monolith in such a way as well. It was just easier to conceptualize and pull things apart one by one to ensure that you couldn't possibly like confuse books logic with users logic. But you don't just need an entry point that you can access from some encompassing server, right? You also need an entry point that can be accessed a little bit more generally. Because let's say you want to find the books for a user, you might make a call out from users to books and then send that back to the client, right? Or maybe you want maybe you don't want to build your Facebook Messenger app. You want your Messenger app to be built. You don't want to build it. You want to give other people tools so that they can integrate your information with them. So now you have to have an external access point where someone outside of this organization can make a call into your book service and say, what books are available at this location? I'll make a scheduling algorithm for when to best pick up and drop off books to get the best books. You don't want to build it, you're not a machine learning guy, but someone else does. So that's where that API gateway comes in, and the concept of an API. This layer right here, actually, this thin layer where you can access all of your different services is your API layer. How many of you guys have heard of REST APIs? How many of you guys know what REST APIs are? Fewer. But no, it's good that you guys know what that is. I wasn't expecting it. I didn't really know what a REST API was until I was thrown into a project and said work on one. So I think that makes total sense. But generally, the de facto way to make an API right now is to use a REST API, which essentially means that you have some server, you have bookshare.com/API, and then on that server you have different routes. So maybe you have /books, right? And that way you can send it a query with the kind of information you want from that books endpoint. Maybe you also have /users that does the same thing, and you have locations, etc. And so you make your 3 microservices. But now you start adding more and more information. To each book you have a genre, and to each genre you have sets of genres. Maybe you're trying to help the machine learning people to understand how to better classify things. So for each genre you have related genres, and for each book you have an author, and you have their related authors as well, which then have all of their information. You can see how the kind of data that you need to return can grow really, really quickly. Because every single time that you want to add a new feature or add some new data to your API, you just kind of have to dump it, usually in a JSON object. And this has pros and cons. On the pro side, you can allow other developers and yourself access to use all of your data as fast as possible. But on the other hand, you end up with slow response times and a really poor developer experience. Because if you have tons of data that you're outputting, now you're relying on the user to read your documentation or just look at that object that you're spitting out to find all this stuff. An alternative is you just have a lot of REST endpoints. So now instead of /books, that might just give you only titles of books, or only IDs of books, but then you have to do /books/authors/names or something. And then that's how you can find the names of the authors, but you won't get anything else. And this also has its con, right? Because now every single time that you want to change something that touches other pathways, you need to update every single other pathway that it touches. Along with just maintaining all of these servers, this is also a confusing developer experience. Because now, as a developer trying to consume your API, I need to read all of your documentation and figure out, oh, calling books won't do it for me. I actually have to call books, authors' names, first name, country of origin, in order to get some useful information. So REST has its ups and downs. Just in case you guys aren't following, I want to step back for a second and talk about what APIs are in general. Just a brief overview. I feel like most of you guys are following along. If not, please do not hesitate to just raise your hand and be like, I kind of missed what you said about such and such. I'm talking kind of fast. I know I can garble words sometimes, so feel free if you're like, not really sure, like you use the word REST, but I don't think you ever introduced it, like just raise your hand. So an API is basically just a black box input-output function. Like any machine, like any application, you want it to go ahead and do something, and you don't care about how it does it. You have a radio that you want to just tune to the right band, and it'll capture some radio waves from the air, do some complicated stuff, and send you back the result. You don't care how it does it. Similarly, you have a barista at your favorite locally sourced coffee shop that you want to tell them your order. You want a tall, soy, flat white, no whip. And you want them to go and make that. You don't know how it's made. You're not even entirely sure what's in it other than the ingredients you said. You don't know what a flat white means, but he's going to come back and he's going to give it to you. That's kind of what an API is. You want to say, I want books. You don't care what database they're sorting. You don't even care if they're pulling random information out, because you don't know. It's not your job. They're just going to give you a list of books. But as an analogy of what we were just talking about with REST, now we can imagine that when your application grows big enough to have enough data that it's unwieldy, you now have two options with your barista. You can say, excuse me, barista, I would like a tall soy flat white. He'll go to his back room and he'll get a tall soy flat white, a macchiato, a frappuccino, 6 creams, 1 sugar. He's going to get a pancake, a waffle. He's going to bring them all back. He's going to say, here you go. You have to find your tall soy flat white somewhere in there, which, you'll probably find it eventually, but it's not great. Or you get to the bar and there are 15 different baristas. Say, I'd like a tall soy flat white. Nope, that's not me. I'd like a tall soy flat white. Nope, not me. I'd like a tall... You just keep going until you find it. And hopefully I'm building up the motivation for why GraphQL exists. I don't know if you guys remember your talk from Facebook. I heard that it was, a bit abstruse, but the basic idea is that it can help to avoid this problem. Rather than having to deal with either over-specification or under-specification, it hits the nail right on the head by asking the client, the actual, user interface itself, to specify the exact kind of data it needs. So for a schema might look something like this. For the book example, you might have, this might not be a valid schema, that's okay. You might have books as a type, and users as a type, and you might have locations as a type. And then under locations, there might be books that are at that location. Maybe not users, because users can go anywhere in the world. And under users, it could have, get... Sorry, I should have given myself more room here. Try again.